Solving logarithm equations, part 2. Remember in the last video, I showed you how you can solve a logarithm equation by converting it to an exponential equation. So if we look at this, this is a common log. Common log means the base is understood to be a 10. To convert this to an exponential equation means that I use the formula log base A of x equals k is equivalent to a to the k power equals x. In this problem, the a is 10 and the k is 1, and the x is actually the 9x squared, everything I'm taking the logarithm of. So this will convert to the equation 10 to the first power equals 9x squared. Now I want to solve this equation. Now this equation is quadratic and it's got an x squared, but it doesn't have an x. So what I want to do is to solve this by getting the x squared by itself. So I'm going to divide by 9. That would give me 10 over 9 equals x squared. And then I want to solve it by taking the square root on both sides. And remember, when I use my square root property, I have to use both the positive and the negative square root. So this will give me the positive or negative square root of 10 over the square root of 9, which is 3. Now, that gives me 2 answers, but anytime you solve log equations, you have to check your answers. So I'm going to check. First, I'm going to check x equals the positive square root of 10 over 3. To check it, I go back and I plug it in to the original equation and make sure that the left side equals the right side. So when I put this in, I'll have log of 9 times the square root of 10 over 3 squared. So this is the log of 9 times 10 over 9, which those 9's would cancel, so I would have the log of 10. The log base 10 of 10 is 1. So the positive answer works. Now let me check the negative answer. The negative square root of 10 over 3. My original equation is log of 9x squared equals 1. So when I plug this in, I'm going to have log of 9 times the negative square root of 10 over 3 squared. And I want to see if that's going to give me this 1 over here on the other side. So let's see. When I square the negative square root of 10, I'm going to get 10. And when I square the 3, I'm going to get a 9. So once again, this left side of the equation is the log of 10. The log of 10 is 1. So actually both of these answers work in this equation. When you have an equation that has more than one logarithm in it, for example, this one we have logarithms on both sides of the equation. We want to get the logarithms on each side combined. We'll use our properties of logarithms, which tells us if we add 2 logs with the same base, that's the same as forming a product of the logarithms. So the natural log of x plus the natural log of x minus 1 is the same as the natural log of x times x minus 1, which is the natural log of x squared minus x. That equals the natural log of 2. Now, similar to what you may have seen before, if the natural log of something equals the natural log of something else, then we know this x squared minus 2 has to be the same as, x squared minus x has to be the same as the 2. So here, I don't even need to do any conversions. I just write this as x squared minus x equals 2. So to solve that, it's quadratic, so I set it equal to 0, and then I factor it. That'll be x minus 2 times x plus 1. So this will give me 2 solutions. I get x equal 2, and I get x equals negative 1. Now, right off the bat, I know that this negative 1 I'm going to have to throw out, because when I go to plug this in right here, the natural log of negative 1 would be undefined. Now, the other answer, that positive 2, let's see what I get here when I check it. This would be natural log of 2 plus natural log of 2 minus 1. So this is the natural log of 2 plus the natural log of 1. But remember that the natural log of 1, or any logarithm of 1, is always going to be 0. So the left side of the equation is the natural log of 2, and the right side of the equation is natural log of 2 also. So the x equals 2 works. The x equal negative 1 does not work. This problem, I have logarithms on the first side of the equation, but not on the second side. So once again, I'm going to use my properties to combine these. This is an addition. So that means I can combine these 2 logarithms into the log base 2 of x minus 7 times x plus 7. Now, I need to multiply this out in here to make it a little bit easier to write out. X minus 7 times x plus 7 is x squared minus 49. So I have the log base 2 of x squared minus 49 equals 5. Now, I do need to convert this to an exponential equation. My base is 2, so I have 2 to the 5th power is equal to x squared minus 49. Once again, I can get my calculator out and see what 2 to the 5th power is 32. So I have 32 equals x squared minus 49. So I'm going to solve this by subtracting my 32 from both sides. So that would give me x squared minus 81. I'll factor this. To get x equals negative 9 and x equals positive 9. Now, I have 2 answers, so I have to check them both. So let me check. The x equals negative 9. I don't have to go very far into this check to see that this one is not going to work. Because if I put a negative 9 in right here, that would give me the log of negative 16. And I can't do log of negative 16. So the log of negative 9, the answer of negative 9 I have to throw out. So now let me check the positive 9. Log base 2 of x minus 7 plus log base 2 of x plus 7. I want to see if that's going to equal 5. So when I put the 9 in, I'll have log base 2 of 9 minus 7 is 2. plus log base 2 of 9 plus 7 is 16. So if you go back and remember what logarithms mean, the logarithm is whatever power you have to raise this number to get this number. So this is the log base 2 of 2. This is the log base 2 of 2 to the 4th power. Remember that 16 is 2 to the 4th power. So the log base 2 of 2 to the 1st power is 1. And the log base 2 of 2 to the 4th power is 4. So I have 1 plus 4 is 5. So the positive 9 is a solution.